Good day, viewers. This is Afe Ademola Johnson, your chemistry tutor and your biology tutor. Please, I will advise you to subscribe, share this video, and then put in the comment section anything, any area you want me to improve. So please share it, share the video, and then subscribe and like the video. So we have started a series of work on stoichiometry. We have done stoichiometry concerning mass, stoichiometry concerning volume, stoichiometry involving number of particles, number of ions, number of molecules. So today we want to look at solution, stoichiometry of solution. So what is a solution? Solution is the combination of solutes and solvents. Combination of solute and solvent. So we mean solution is equal to solute plus solvent. Now, what is the solute? So solute is a part of the solution which dissolves in the solvent. Then while solvent is a part of the solution which dissolves the solute. Now, every day in our day-to-day activities we prepare solution. You pour garri inside water. The water is the solvent, while the garri is the solute. So you have prepared solution. Now, but there is in that type of solution, you do not measure the mass of the garri you are pouring. You do not measure the volume of the solution. You just take your discretion, use your discretion to pour certain amount of garri inside water. That solution is not a standard solution. Then, what is a standard solution? The type of solution we recognize in chemistry is a standard solution. Standard solution. Standard solution is the solution we recognize in chemistry. What is a standard solution? A standard solution is a solution whose concentration is known. A standard solution is a solution with known concentration. A solution that will know the concentration. That is a standard solution. Now, then what is concentration? Concentration of a standard solution. Concentration of the standard solution. Now, this is the amount of the solute which dissolves in 1 dm³ or 1000 cm³ of the solution. So that is what we mean by concentration. The amount of the solute that will dissolve in 1 dm³ or 1000 cm³ of the solution. And that is concentration. Types of concentration. There are two types. There are two types of concentration. These are, we have mass concentration. Mass concentration. And two, we have molar concentration. Now, what do we mean by mass concentration? What do we mean by mass concentration? So let's look at mass concentration. Mass concentration. Mass concentration. This is the amount of the solute in grams. In grams G, which dissolves in 1 dm³ or 1000 cm³ of the solution. So, you know, the SI unit of mass is gram. So we call it mass concentration because the amount of the solute that dissolves in 1000 cm³ or 1 dm³ of solution is measured in what? In grams. And from there, the SI unit of mass concentration is grams per decimeter cube, which is represented as G/dm⁻³ or G/dm⁻³ If you remember law of indices in mathematics, I will put, if I'm not putting slash, then I'll put -3. But if I'm putting slash, I will not write dm and put ordinary 3. So that is the SI unit of mass concentration. Now take note. Now mass concentration is the concentration of a mass solution. There is a mass solution, there is a molar solution. Now, what is a mass solution? A mass solution or gravimetric solution is a solution, is a standard solution whose solute per dm³ of the solution is measured in grams. So the amount of the solute in a mass solution is measured in grams. This year's NECO, the one they wrote yesterday, they asked them to define molar solution in the theory. But before we go there, now let's quickly look at molar concentration. Molar concentration. This is the amount of the solute in mole that dissolves in 1 dm³ or 1000 cm³ of the solution. Amount measured in mole. Now the SI unit of molar concentration is molar, capital letter M, or mole per dm³. If I will put slash, or mole dm raised to power minus 3. That's the SI unit of. Then take note. Then what then is molar solution? A molar solution now is a solution whose amount of solute per dm³ of the solution is measured in moles. So the amount of the solute that you dissolve inside the 1000 cm³ solution is measured in what? In mole. That is why it's mole in 1 dm³. Per means in 1 dm³. Now let's quickly look at something else. Now, what are we looking at now? Let's look at primary standard. Now, let's look at primary standard. Primary standard. What is a primary standard? A primary standard is a reagent or solute used in preparing a standard solution. Due to his what? Due to his high degree of purity and stability. Yes. We still have another one called secondary standard. That one is also used to prepare solution, but not standard solution. It has high degree of purity, very pure, and stable. Now let's look at common examples. Common examples of primary standard are: number one, we have sodium trioxocarbonate 4. Sodium trioxocarbonate 4 decahydrates. Now, 2, we can have oxalic acid dihydrates. Oxalic acid dihydrates. We can have potassium hydrogen iodates. so many of them, and so on and so forth. All these are primary standards. Now, what are the properties of a good primary standard? Features of a good primary standard. Number one, it is highly pure. Highly pure. And why must it be pure? Why is the purity important? If you dissolve it inside water, you are sure that it is only that thing you dissolve in water, nothing else has been added to it. Number two, it is soluble in water. Can dissolve in water properly. It has high equivalent mass. 4. It is not hygroscopic. 5. It is not deliquescent. 6. It is not efflorescent. It does not effloresce. So, it is not efflorescent. Now, I have seen a question before, and that question is that why is sodium hydroxide not often used to prepare a standard solution? Why is sodium hydroxide not often used to prepare a standard solution? The reason is that it is deliquescent.